In this section, we go over the whiteboard full of deep learning tools for your arsenal that we introduced in sections 2.2, 2.3, and 3.1 of my prequel, Deep Learning with TensorFlow live lessons. This here will be a very brisk overview, only a few words about each of these concepts, so that we can use this whiteboard as a starting point for the essential theory we're about to learn in these Deep Learning for NLP live lessons. So if you're unfamiliar with these concepts, be sure to go over the relevant sections of my prequel live lessons. Over the course of the current live lessons, we'll add tools to our arsenal, gradually adding them to this board, particularly to the layers section, and apply them to solve natural language tasks. Artificial neurons, of course, are the base unit of our deep learning networks. We learned about the perceptron in our previous live lessons as an introduction to artificial neurons, but only taking in binary inputs and providing binary outputs, the perceptron in practice isn't very useful for us for our contemporary deep learning models. So we'll go ahead and cross that one out. Sigmoid neurons transform the output and build upon the kind of base perceptron by having a value from 0 through to 1. And that makes it a lot more useful. And so we will be using it in these live lessons, particularly in output layers. Tanh neurons will also be making use of in these live lessons. Those are similar to sigmoid units, but they have a floor of -1 instead of 0. They, in practice, learn a bit more quickly than sigmoid neurons, and we'll be using them in some sequence-specific neuron types that we will learn about in a little bit. We'll also be using rectified linear units. Those will form a big part of the networks that we're using in these live lessons. They learn very quickly, love them. In terms of cost functions, in the previous live lessons, we talked about the quadratic cost function a lot because it's simple to visualize and understand the difference between the outputs that you're looking for from a neuron and the outputs that the neuron's actually providing. In practice, they don't learn nearly as quickly as cross-entropy cost function, so we're going to just go ahead and cross off the quadratic here as well. So we'll really only be using cross-entropy cost function in these live lessons. Gradient descent, of course, is used to actually learn from the cost, so to take steps in the direction of a network that is giving us the outputs that we want. And learning rate is a key factor in gradient descent, making sure that we're not taking steps that are too small because then learning is very slow, or too large because then we can miss the optimal minimum. We can just keep stepping right over it. We also need to take into account our mini batch size, so that's a hyperparameter that we will be considering in all the networks that we build in these live lessons. Simply the number of samples that we're considering in any given cost function or gradient descent calculation. And we will also be taking advantage of second order gradient descent optimizers, particularly Atom in these live lessons. And the advantage of them is that they learn quickly when the network is, when there's a lot of learning to happen, particularly in the beginning. And then as we converge on the optimal global minimum or a local minimum somewhere, the second order gradient descent optimizers will slow down and narrow in on that perfect spot. So it means that we don't need to worry about setting our learning rate too much manually ourselves. In terms of initialization, we will be initializing all of our networks with either Glorot uniform or Glorot normal initialization. This ensures that that throughout training, particularly in the beginning, our weights have an optimal shape for efficient learning in the beginning. And in Keras, which we'll be using a lot of, this is taken care of automatically. We don't even need to specify it explicitly. To reduce overfitting in our networks, we can use the standard machine learning approaches of L1 or L2 regularization, which penalize having unnecessary extra parameters in the model. We'll be making heavy use of dropout in these live lessons, which involves dropping out a proportion of the neurons in any given run. And that's a hyperparameter that will move around a little bit. So in some cases, we'll be dropping out half of the neurons on a given update. On others, we'll be dropping out a fifth of them. And data expansion is another option for reducing overfitting. We'll be working with fixed size data sets for these live lessons, but we'll talk about using larger data sets quite a bit. The final section here is layers. So there are a handful of layers that we became familiar with in our previous live lessons. We'll be adding to those in these ones. The dense or fully connected layer is a kind of layer where all of the neurons in one layer connect to all of the neurons in the layer above. And this is a bread and butter layer for deep networks. We will be making use of them again in these live lessons many times. The softmax output layer is particularly useful where you have multiple classes that you are getting a probability output for from your network. And in these live lessons, we'll be using a sigmoid neuron more often in the output because we'll often only have two classes that we're distinguishing between. I'll talk to that a little bit more later on. Another type of layer is a max pooling layer, which takes some values from a number of neurons, and it reduces that, say, from 4 values to 1. It just takes the maximum value from all 4 of those. So in the previous live lessons, we were working with machine vision applications a lot. So we might have had 2 by 2 matrices that we were passing along and taking only the strongest, the highest value from those 4. So that was the max pooling layer then. In these live lessons, working with natural language data, we'll be working with sequences. So these will no longer be 2 by 2. They'll be one-dimensional max pooling layers of some length. We'll also be working with flattening layers again in these live lessons. Those simply involve changing the shape as we move from one type of neural layer to another. They don't really do any processing. They just change the shape, say from a 2-dimensional to a 1-dimensional, or from a 3-dimensional to a 2-dimensional shape. And then finally, convolutional layers. We talked about them near the end of the previous live lessons. These allow us to identify features in an image across that whole image and space invariant. So you might identify a particular shape of edge, and wherever that particular shape is, anywhere on the image, a particular convolutional filter will pick that up. Again, we're not focused on images in these live lessons. We're working with sequences of language data. So just like the max pooling layer, our convolutional layers will no longer be 2-dimensional. They'll be 1-dimensional. And instead of looking for aspects of an image, like an edge or a corner, they'll be looking for particular words or particular sequences of words. All right, so that's it for this quick recap. I'm looking forward to filling in more information here for you guys to play around with and get processing some natural language. Up next, we're going to do a look at a later notebook. You'll get a sense of the kinds of skills that you'll be developing over the course of these live lessons.